بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we will continue talking about exponential functions, and specifically we will talk about the derivative of an exponential function. Let's see how do we derive an exponential function. Let f be the function defined on an interval I as f of x is e to the power ux, and we usually state it as e to the power u. So its derivative would be f prime of x equals u prime of x times e to the power u of x. And we usually say f prime of x is u prime e u. Let's see this example. We need to find the derivative of each of the functions. When f of x is e to the power x, so its derivative would be, we leave it as it is and we multiply it by the derivative of the exponent, and in fact the derivative of x in this case is 1, so f prime would be e to the power x. So the derivative of e to the power x is e to the power x, is itself. Now what is the derivative of e to the power minus x? It will be, applying the property u prime eu, it will be minus e to the power minus x. So we derive the exponent, its derivative is minus 1, and we multiply it by the quantity. Now this case, apply the same property, we get minus 3 e to the power minus 3x plus 2. So again and again, we write it as it is and we multiply it by the derivative of the exponent, which is negative 3 in this case. Now here, we leave the 3 alone, we multiply it by the derivative, we get 2x into e to the power x squared plus 2, and it's better to be simplified as 6x e to the power x squared plus 2. Now this expression, the derivative of 2x is 2, the derivative of negative 1 is 0, minus, and the derivative of this quantity is minus 2 e to the power minus 2x, and if we multiply by minus 2 by minus, we get plus 2. Now here you see that ex is going to be embedded in other functions. Remember, here we have u times v, and here we have pluses and minuses. So if we want to derive, the derivative of negative 3 is 0, the derivative of x is 1, which is here, and this is of the form u times v, so we derive it as u prime v plus v prime u. Remember, we have to memorize that the derivative of ex is itself, because this simplifies our work. So the final answer would be this function. Now, this function, this is of the form u times v, we get u prime, which is 2, into v, plus v prime, which is ex itself, into a u, and if we simplify it, we get 2x plus 3 into ex. Now part h, this is of the form u times v also, we get u prime, which is 2 into x plus 1 into v, plus v prime, and v prime in this case is minus e minus x into u, and if we take e minus x in common, we get 2x plus 2 from the first term, and we get minus x squared minus 2x minus 1 from the second term, and after simplification we get minus x squared plus 1 into e to the power minus x. Here we need to find the derivative of each of the functions below. Try to do it alone. Well, if we want to derive, the derivative of ex is ex, the derivative of e minus x is minus e minus x, and multiplied by this negative sign becomes positive. Now try to do also this one alone. Remember all the properties of derivatives. Well, the derivative of minus 2x is minus 2, and this is of the form u times v, so this is minus 2, and for the first one we get u prime v plus v prime u, and if we take e minus x in common, we get 2x minus x squared, and this is minus 2. Try to do this one alone. Well, this is of the form u over v, so it becomes u prime, which is 1 minus ex, into v minus v prime, which is 1 plus ex into u over v squared. And if we expand the numerator, we get such an expression. After simplification, it becomes 2ex minus 2x ex over this quantity. Now let's see the second application. This is f of x, and the question is to prove that f is strictly increasing. Try to do it alone. Remember, strictly increasing means that the derivative is strictly positive. So the derivative in this case is, this is of the form u over v. It is u prime v minus v prime u over v squared, which is ex plus e2x minus e2x, which is ex over this quantity. This is strictly positive, so we can say that f is strictly increasing. Thank you.